All right, today we are going to do a little factoring review. Most of you are pretty good at factoring already, but just to kind of remind you of some of the different methods that we've learned for factoring. We're going to use factoring in our next chapter about rational expressions. All right, so the heading for your paper is Factoring Review. Okay, and then I want you to take your paper and I want you to like fold it in half. So you can just fold it over. You don't have to fold it all the way. Just kind of so that you have two parts of your paper. So we're going to fold along here so we've got like a nice little line kind of going down the middle of our paper. And our examples we're going to keep over here to the left, and we're going to use the right-hand side again here in a minute. So if you want to, you can draw a line down that. You don't have to draw a line. Just don't work past that. Okay, so the first kind of factoring that we learned about was factor the GCF. Okay, so we're going to work a couple of problems with this. You may not remember exactly what that means right now, but we're gonna work a couple of problems and it'll jog our memory. All right, the first example is 15x to the third power plus 5x squared. All right, 15x to the third power plus 5x squared. Okay, what we did here, this is the problems like we're undoing distribution. So we think about what the greatest common factor is of these two terms, and then we do our set of parentheses. Okay, so I'm thinking, what's the biggest number that goes into 15 and goes into 5? And I know 5 goes into 15, so that is part of my GCF. Then I see that they both have x's, and so we remember we pick the one with the smaller exponent. So I have x to the third and x squared, so I'm going to factor out x squared. All right, so 5x squared is the GCF, but we're not done. We actually have to factor, which means that we need our set of parentheses. All right, and this is where we do our division. 15 divided by 5 is 1, or sorry, it's not 1. 15 divided by 5 is 3. Okay, we had x to the third power. We took out x squared, so we need x to the 1 power. And we remember that we don't really need to put that little 1 power there, but sometimes it helps just to make sure we're keeping track of our work. All right, then we have positive 5 divided by 5, which is positive 1. Okay, and we had x squared. We took out an x squared, so we don't need any more x's on this term. We just close our parentheses. Okay, and this is now factored. So that's all we're doing with these first few problems. All right, is just making sure that we remember how to factor the GCF. All right, so let's try another one. Number 2. 18x squared minus 27. Okay, 18x squared minus 27. Well, I need numbers that go into 18 and go into 27. All right, honestly, I'm not great with 27, so let's find the things. We're going to pick the smaller number, and let's write our factor pairs. 1 and 18, 2 and 9, and then you may need to have a calculator out to check this, but 3 and 6 both go into 18. So I'm looking for all the things that multiply together to be 18. Okay, and then that's all of them. Okay, now I'm going to take these and I'm going to test to see if they go into 27. 18 does not go into 27 evenly. 27 divided by 9, that does work. So I know 9 is part of my GCF. So 9, and then just like up here, I'm looking to see what x's they have in common. This one has x squared. This one actually doesn't have any x's at all. So I cannot factor out any x's. So I just start my parentheses. The whole greatest common factor of this one is 9. 18 divided by 9 is 2. We had an x squared. We didn't take out any x's, so we're left with x squared. All right, negative 27 divided by 9, and we got to make sure we notice that negative or minus is negative 3. It didn't have any x's. We didn't take out any x's, so we still don't need any x's. Okay, so 9 is outside the parentheses, 2x squared minus 3 inside the parentheses. And we're finished. We factored the GCF. All right, so that's two problems like that. And now go ahead and draw like a line underneath that. So we're kind of creating some space right over here. And we're not going to use that just yet. All right, our third example in this section is going to be doing, we're going to call it quick MARF. Okay, we talked about this a little bit, but actually these are going to be really fast MARFing problems. All right, we talked about the fact that when our problems start out with x squared and there's no number in the front, our magic numbers are actually part of our answer. So we'll see what we mean by that. We're going to do like 4 of these, so we'll really get good at it. Okay, so we remember when we MARF, for these we only actually have to do the M and the A steps, so you don't have to write out the R and the F steps. Okay, we multiply to be the first number, which in this case is 1, times the last number, 8. So multiply to be 8, add to be that middle number, -9. So we're looking for our two magic numbers. They multiply together to be 8. They add together to be -9. Well, I've got 1 and 8, 2 and 4. Those are the only things that multiply together to be 8. 1 and 8 are the only ones that have a chance of making 9. A negative times a negative would give me a positive multiply and a negative add. So -1 and -8. All right, now we get to skip the R and the F steps. When we have x squared at the beginning, this is quick marf again, remember, we can take our magic numbers and they are what go in the parentheses. So we're going to have x's at the beginning and then -1 and -8. So these are really quick little problems, okay? So find your magic numbers and then they go with x's inside the parentheses. All right, let's try a few more of those. All right, number 4. X squared minus 5x, and you should be writing all of these down with me. I will be collecting this and making sure that it's done. Okay, x squared minus 5x minus 14. Okay, again, we're going to do our M and our A steps. We multiply the front number, which is 1, and it's going to be 1 every time because this is a quick mark. 1 times -14 is -14. Add to be -5. Okay, so you're finding your two magic numbers. I'm going to actually just give you a second to kind of find those two magic numbers if you're not sure. Remember, if you're in any doubt, start listing the factor pairs of 14. 1 and 14, 2 and 7. Okay, and those are really the only numbers that multiply together to be 14. So the only ones that have a chance to make 5 are 2 and 7. Okay, so then we just kind of have to play with it. -2 times 7 is -14, but -2 plus 7 is +5, so that doesn't work. Okay, so the negative must need to go on the 7. 2 and -7. And always double check your work. 2 times -7 is -14. 2 plus -7 is -5. Okay, and now just like up here, we're ready to jump to our two sets of parentheses. X is in the beginning for both, and then +2 and -7. So x plus 2, x minus 7. All right, let's just do one more of these problems. All right, number 5. Okay, and we're going to write this down. X squared plus 12x plus 35. Okay, and I'm just going to pause here for just a couple seconds, and I'm going to let you just work this one out. So I want you to do what we just did on the previous two and try to get your answer on that. If you can't find your answer, if you're not sure what to do, then just wait. I will work through it here in just a minute. If you've already gotten an answer, check with your neighbor, make sure that they agree with you. Okay, I'm going to start working through this problem. We multiply to be 35 and add to be 12. Okay, hopefully we don't have to write out factor pairs every single time. I'm thinking about numbers that multiply to be 35, okay, and add to be 12. Well, the first thing that jumps in my mind that multiply to be 35 are 5 and 7. And 5 plus 7 are 12. Okay, so 5 and 7 are my magic numbers. I can jump straight to my answer, x plus 5, x plus 7. Okay. All right, and we're leaving this whole side blank over here for right now. So everybody should flip their papers over. Okay, so don't write on that second side yet. All right, and we kind of have the same line over here. It's just kind of stuck over closer to the side. All right, so let's do one last type of factoring. We talked about something called difference of squares. Okay, difference of squares is the last kind of factoring that we're going to do. All right, an example here, okay, difference of squares. We're going to do number 6, and we're going to say x squared minus 9. Now, I'm actually going to grab a little scrap of paper and show you how we did this in the last chapter. But then I'm going to show you a little shortcut so that you don't have to do this. You don't have to work this out the long way every single time. Okay, so here's my scrap of paper that I'm just going to put here so that I don't actually write on my paper. So you're not writing this down right now. I don't want you to go through this. This is a problem where we have x squared at the beginning and a constant at the end, and it's called difference of squares because it has this minus sign inside. What we did when we learned factoring was we put a 0x in the middle, okay? And again, you're not writing this down, okay? We multiply to be -9, then we add to be 0, and our magic numbers were opposites. And in this situation, -3 and 3 multiply to be -9 and add to be 0. So we get the answer x minus 3, x plus 3. Well, I'm going to actually show you a shortcut where you don't have to do any of this work right here at all. Okay? All you have to do is take the square root of the first part. X squared, the square root is just x, and that goes in each set of parentheses. And then you take the square root of the end part, 9. The square root of 9 is 3. And then one set of parentheses gets a minus and one gets a plus. Okay, so we can kind of do these really, really quickly with a nice little shortcut there. All right, so the answer here, the square root of x squared is x. The square root of 9 is 3. Okay, and then one gets a minus, one gets a plus. All right, so let's do a few of these and make sure that we see what we're doing here. All right, so number 7 is 25x squared minus 16. Okay, so again, I've got something that I know the square root of at the beginning and the end, and a minus sign in the middle. That's how I know it is difference of squares. All right, so I'm going to do my two sets of parentheses. All right, the square root of 25, if you're not sure, the square root of 25 is 5, so that goes at the beginning of each one. The square root of x squared is x, so 5x at the beginning of each set of parentheses. And then the square root of 16 is 4, so that goes at the end of each set of parentheses, and then one gets a minus, one gets a plus. And it doesn't matter if you put the plus at the beginning or the plus at the end. Okay? All right, I'm going to give you guys a couple more of these to do, so you should be trying these. Number 8, let's do 64x squared minus, let's just see, minus 9. Okay, so you try this one. I'm going to give you a couple minutes to get that done. All right, if you don't have your calculator out, you may need your calculator out today, all right, to find the square roots of these numbers. Okay, the square root of 64 is 8, and then the square root of x squared is x. The square root of 9 is 3, and then one needs a plus and one needs a minus. It doesn't matter if the first set of parentheses is the plus or the minus. Okay, one gets a plus, one gets a minus. Let's try one more, and then I'll tell you what you need to do over here on the right-hand side. All right, so one more problem. We will do 100x squared minus, oh gosh, let me think of a good perfect square, 49. All right, so you do this one. Okay, hopefully we're getting pretty good at these at this point. We know that the square root of 100 is 10. Square root of x squared is x. The square root of 49 is 7. And then one gets a plus and one gets a minus. Okay, so we should be getting pretty good at those problems now. We don't have to actually put the 0x in the middle. We can just follow that pattern. All right, now here's what I want you to do on this other side of the paper. Okay, so you're going to have 1, 2, and then over here on the back, 3 sections where you're going to be writing to me. Okay, and what you're going to be writing is how can you tell it is this method? Okay, how can you tell that it's this method? Tomorrow in class we're going to do an assignment that's all kinds of these problems, but they're going to be all mixed up all over the page. So you're going to have to be able to look at the problem and know what method to use for that problem. Okay? So you're going to have to be able to look at it and say, oh, I know that's a MARF problem, and here's how I know. Or I know it's a GCF problem, and here's how I know. So you're writing what you see in the problem to let you know to factor it this way. Now, don't tell me what you see in the answer, because that won't be there. You have to figure out the answer for yourself. So what do you see in the problem that helps you know that it's this method? So you're going to write me a couple sentences here, here for morphing, and then on the back you're going to write a couple more sentences about how you know that it is that method, so that tomorrow when we're doing work and we're practicing these methods, you will know exactly what to do for each problem. Okay, the teacher is going to collect these, so please finish writing and explaining how you know these. I want good explanations. We will go over them in class tomorrow, and I will be looking over these problems and your explanations. So please make sure you've taken complete notes and that you write in these extra sections about how you can tell it's this method. So 1, 2, 3 places for writing, okay, and make sure that you have all 9 examples done on your paper. All right, thank you, and please be good for your sub.